is a very misunderstood and underappreciated fuel. It often gets slandered and described as cheap and nasty. But why? What's wrong with it? Do you really understand ethanol? This fuel is a sustainable liquid derived from biomass. It's a colourless, flammable, oxygenated hydrocarbon with a boiling point of 78 degrees Celsius, and it has a very similar density to regular unleaded petrol. Bioethanol is produced using a fermentation process of raw materials such as sugarcane, corn and wheat grains, and cellulose products. In some countries, this fuel is made from waste biomaterials so as not to interfere with food production, while in others, some of the traditional food harvest is diverted for fuel production. There have also been innovations into the production of synthetic ethanol, which is derived from non-renewable sources like coal and gas. The refinement process for bioethanol is very similar to a commercial distillery, although in this process the feedstock is first converted into glucose. The creation of ethanol via fermentation separates the base glucose molecules into both ethanol and carbon dioxide molecules. Combustion of bioethanol fuel emits relatively low hydrocarbon emissions. In fact, the majority of byproduct is made up of carbon dioxide and water. When compared with the combustion of a hydrocarbon-based fuel, tailpipe emissions are considerably less. 100% ethanol fuel is not commercially available at the pump for everyday driving. But what we do have access to is an ethanol blend. This is available as two different types. The names of each indicate the percentage of ethanol the fuel contains. E10 is blended with regular unleaded at a value of up to 10% pure ethanol. E85 contains between 70 and 85% ethanol fuel blended with unleaded petrol. In its pure form, bioethanol has a research octane number of around the 115 mark. This is very similar to avgas and other racing fuels. The RON of a fuel is a measure of its ability to resist engine knock or detonation. The higher the value, the greater the resistance to unwanted engine detonation. Spark ignition engines using high compression ratios require a fuel with a high octane number, or serious damage to the combustion chamber will occur due to uncontrolled detonation. Generally, high compression ratio engines develop higher levels of NOx emissions, and they must also be sufficiently designed to cope with the increased cylinder pressures developed. Unfortunately, this adds considerable cost and complexity to an engine that might otherwise be designed for a budget vehicle. Engine designers must achieve a balance between compression ratios, usable torque, emissions output, and cost when specifying a fuel type for their design. What this means is that the majority of spark ignition vehicles on our roads require a fuel with an octane rating between 90 and 100. When ethanol is blended with standard unleaded petroleum, which has an RON of 91, the new E10 fuel is rated at close to 94 RON, making this fuel suitable for the majority of our vehicles. The energy density of E10 is marginally lower than unleaded petroleum, meaning a slightly higher fuel consumption for the same torque output. Generally, the purchase price for E10 is set by federal guidelines to be substantially less than the equivalent unleaded fuel. Ethanol is a form of alcohol, so it's hygroscopic, meaning it absorbs water from its surrounds. Just like hydrocarbon liquids, it is also marginally corrosive and can damage fuel components that contain large amounts of natural rubber. When sold as a fuel, corrosion inhibitors in the form of fuel additives are mixed with the blend that inhibit or suppress the corrosive properties of ethanol, thereby preventing corrosion or rusting of the fuel tank and degradation of the other fuel system components. We always say that when diagnosing a fuel fault, we should take a sample of the fuel and check for contamination. Well, we can also determine the ethanol content of this sample quite easily, using what is known as the water extraction method. Pour 10 cc's of water into a jar and mark the level on the side. Then add 100 cc's of the fuel sample. The total liquid volume should be 110 cc's. Mix the sample well. Let the jar sit while observing. If there is any ethanol in the sample, it will absorb the water and then separate from the unleaded fuel due to its greater density. We can calculate how much ethanol is in the fuel by measuring the rise in the water level. A 10 cc rise equals a 10% ethanol mix from a 100 cc sample. High performance engines that are designed with high compression ratios can take advantage of the properties of high octane E85. But it's not just about the octane number when engineers choose a fuel for their design. E85 is a blend of ethanol and unleaded petroleum fuel, with the ethanol content sitting around the 85% mark. Because of its ultra-high oxygen content and energy density levels, E85 has a stoichiometric air-fuel ratio in an engine of 9.8 to 1. This means that under ideal conditions, 9.8 parts of air per 1 part fuel by mass will be consumed by the engine. This is roughly 1/3 more than standard unleaded fuel in the same engine, with its stoichiometric ratio of 14.7 to 1. In other words, an engine will consume more E85 than regular fuel for a given engine speed and load. The designers of the engine and fuel delivery system must take this air-fuel ratio into consideration by altering the time the injectors are open, the quantity of fuel delivered, the amount of ignition advance required, and the feedback value from the lambda sensors. An engine that's tuned for and operating on E85 will develop up to 30% more power and torque than its standard unleaded counterpart. While this is okay for a race car that's towed to a track, it's just not practical for a conventional vehicle. The increased fuel consumption means more trips to the very few service stations that offer E85 for sale. Manufacturers have solved this dilemma with road production models by designing them to run on all unleaded fuel types, including E85. We know them as flex fuel vehicles. Their fuel systems are nearly identical to a conventional type, with the exception of an ethanol fuel sensor mounted in the fuel delivery line, which detects the ethanol content of the fuel. The flex fuel sensor fuel is passing through the delivery pipe and signal this information to the engine control module, change from its and emission map over to its E85 program. In this mode, the fuel pump module may increase the pump speed to supply a greater volume of fuel. The ignition timing may advance to aggressive levels due to E85's RON of 105. The valve timing may be altered to increase overlap and valve lift, and the injector pulse width may be lengthened. One of the main advantages of using ethanol as a fuel is that it's truly renewable over its entire life cycle. Ethanol begins its life as carbon stored in biomass. This is converted to ethanol liquid, which is burnt as fuel that emits water and carbon dioxide. Photosynthesis converts the carbon back into biomass to be used in the next cycle of ethanol production. So, is ethanol fuel as bad as they say? Well, the answer is no. It really isn't. As always, keep training. Thanks for watching.